Chapter 9 shows off PD2D on a very difficult nonlinear partial differential equation, the KPI Wave Equation. You can see this is fourth order in X, second order in Y, and this involves a derivative with respect to X and T. And certainly PD2D can't handle that format. But by introducing two new variables, v is equal to u sub x, w is equal to uxx, you can reduce the equation to this form, and then we have these three partial differential equations that PD2D can handle. So now we're going to show the solution in a case where we have two waves headed toward each other diagonally. We start out with two separate waves headed for each other diagonally. They'll pass through each other and continue on the other side. Unfortunately, this is a little slow on this computer. Strangely enough, it's actually possible to solve this difficult equation analytically, and you can compare the PD2D solution with the true solution, and they agree fairly well. You can see they pass through each other almost transparently. This equation has some application in ocean waves. Okay, we're finished with this oblique collision example. Now let's do one where the initial conditions are very different. Same differential equation, but different initial conditions and very different behavior. Okay, this time we have a large wave behind a smaller wave, and the large wave actually goes faster than the smaller wave and overtakes it and goes through it. Again, it's going slowly. It looks like the larger wave is just recombined with the smaller wave, but it's going to emerge and go past the smaller wave in a moment. We're going out to 10 seconds. Now finally the faster wave is starting to emerge ahead of the smaller one. Okay, we're done with this experiment. The thing that makes this problem so difficult, besides the nonlinearity, obviously, is the sharp moving peaks. And PD2D has to adaptively refine the triangulation and move it. In other words, it's got to re-adaptively refine it every few time steps. And this shows some of the triangulations. This is the beginning of the oblique solver. Remember, there were the two peaks, and PD2D automatically refines the triangulation around the peaks. And the triangulation moves with the peaks. And here is the triangulation when the two peaks are about to collide obliquely. And here's the adaptive triangulation after the two peaks have passed through each other. The book shows what happens when you try uniform triangulation with the same number of triangles. The results are much, much worse. It's very important to have the triangulation refined adaptively because of these sharp peaks. And here's the triangulation for the other case where you have a large wave behind a smaller wave at the beginning. And here's the triangulation when the larger peak has caught the smaller one and they look like they're separating vertically. And at the end, after the larger peak has passed through the smaller one.